Welcome to the short presentation here about being able to analyzing charts. What exactly is this? It's just a small presentation to make sure that you have understood the approach charts of this three. It's going to be very short. We're looking at two different approach charts here for Copenhagen. A few things that of course is important to look at when you're looking at an approach chart like this. We're starting with the one to the left. This is the star into Copenhagen. Of course, you need to always be able to identify the different routes. Um, Another thing you always want to keep in mind of is looking at the MSA, making sure that you know what the altitudes are, or at least what the highest altitude are. We're gonna come back to that in a little bit. Generally, when you see charts like this, you will also have a transition altitude written on the chart, 5,000, but you'll notice that you will not have a transition level. This is because transition levels are variable and change from day to day, depending on the QNH, as I'm sure you know. There is a shortcut in Euroscope also to find it. You can ask your mentor for that, and he will help you find the table in Euroscope that will tell the different transition levels. Alternatively, as you know, the ATIS will tell it as well. I think that's important to know, of course, that you normally do 250 knots below flight level 100. That you have, for example, here in Copenhagen as well. You always make sure you read all the notes for the different arrivals. In this case, it's actually 250 after the termination points, which does more or less end at flight of 100. You see Trano at 120, Corsa 110, Coop is 100, this has 5,000. Also keep in mind, this is very important, once you're descending people to flight of 80 inbound to a point, they have to be level 15 miles before. So you always want to look at these charts and kind of identify how they look. Why are they like they are? Moving over to the approach chart, we have this again with the MSA looking like this. Now, there's a few things that you should really take into consideration when you're doing this. First of all, is how far can you descend the aircraft? You will be told later on in the Billund presentation, where the MSA is a little bit higher, that you can't just descend people below the MSA. So that means the most important one is in Copenhagen right here. You should not descend people to 2000 because that the MSA is 2100. This is because of the obstacle line right here. So these things you have to look at the approach charts and kind of identify, okay, so we know 3000, okay, and then if you want to descend them here below, well, either you have to say radar controlled or you have to wait until they're passing this line or being a bit closer. Same with these two down here. If you wanted to send people all the way down to 1,500, well, you really have to make sure that they are radar controlled. So try to identify obstacle from the different MSA sectors. So here you have this one, 1,083. That's why you need a 1,000 feet margin. You got a 1,700 MSA, which is probably due to Øresundsbroen right here, giving up to around 700 feet. And then at the end, you have a 1,600 MSA, which is probably due to an obstacle, either this one or one slightly further away. So another thing you always want to look at your charts as well is where does the ILS start? ILS normally starts here, either 3,000 or 2,000. It can be different things. But you want to have an idea of where these starts. Another very, very important thing you really need to look at is the full procedure. This is something that you may not have heard a lot about. Full procedure is for when you can't give vectors. All approaches have a starting point, a beacon or an RNAV fix of some sort where you can start the procedure. Now, Copenhagen is no different. We can just take the Copenhagen as an example. It has a navigation aid here called Kastrup VOR, and the full procedure is shown on the plate going out here on the radial 023 out to a distance of 17 miles. Then he turns around, intercepts the final approach course, and then he flies into the ILS. There are two depictions of this. One is top down here, showing you the path, and the other one is actually in profile shown here. You can see the same thing. Here is the VOR. Here's the outbound, the radial 023, going out to the distance, no, that was wrong. Going out to a certain point at 3,000. In this case, you know it's distance 17 from Kastrup. It turns back 3,000 feet, and then at distance 9.3, it starts the 3-degree glide slope. This you need to look at all the plates and have an idea so that if someone asks for a full procedure approach, you actually can look at the plate and understand what is a full procedure. This is normally used either if people request it or if you don't have radar coverage. That is more or less it. Take a good look at all these different instrument charts. You can either take a look at the Navigraph or at the or on the Naviair website. It's basically your choice. Thank you.